Geometry, note section 4.3, just a quick review of what we've done so far in this chapter. We have established different classifications of triangles, whether by the lengths of their sides or the measure of the angles. We have talked about an extremely important definition, the definition of congruent triangles, which is two triangles are congruent if and only if their corresponding parts are congruent. What's cumbersome about that is that you have to know the measures of all three angles and all three sides to have 6 pairs of congruent corresponding parts to prove two triangles are congruent. Fortunately for us, in the previous section, we learned of the side, 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 and the side included angle side congruency postulates. These postulates enable us to only have to know 3 parts of the two triangles in order to be able to tell if they're congruent or not. As we continue with this section, section 4.3, we're going to have 2 other quote-unquote shortcuts that we can use to determine if these triangles are congruent or not. The first one being the angle-side angle congruency postulate. ASA. If 2 angles in the included side of one triangle, so let's draw that. So we got a triangle, we got 2 angles in included side. We'll call this triangle BIG. If 2 angles in included side of one triangle are congruent to 2 angles in the included side of another triangle, so let me draw another one. Two angles in included side, then the conclusion that we can make is that these 2 triangles are congruent to each other, which in turn tells us that the corresponding angles and corresponding sides have to be congruent as well. That's what it means for 2 triangles to be congruent. That's 2 angles in included side. Next, we have the angle-angle side congruence postulate. This one has the word corresponding in it, where the other ones didn't, so this is important. If 2 angles in the non-included side of one triangle, so let's draw this. Two angles, non-included side, are congruent to corresponding 2 angles inside of a second triangle. Now here's why the corresponding comes into play. Depending on how you look at this, if you go around the 2 angles, angle side, it's 2 arcs, 1 arc side. This one is 2 arcs, 1 arc side. If we had marked this like this, these are not corresponding sides. So it's important that we have corresponding sides. The conclusion we can make from this is that triangle arm is congruent to triangle pit, which means all pairs of corresponding sides and angles are congruent. Now, before we continue, we have 4 of these quote-unquote shortcuts: side, 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 angle, side, angle, side, and angle, side, angle. Sometimes memorizing what doesn't work is easier and less work than memorizing what does work. There are 2 of these postulates that don't work. These are non-postulates. One of those is the car company, the company that you call when your car breaks down as long as you have a membership, and that is AAA. The other one that doesn't work is angle side side. Now there's an old saying where I grew up, never make a AAA of yourself by using these postulates in the wrong way. These do not work. If you do these backwards, AAA and SSA, it still doesn't work. So you can memorize these two. This is easy to remember for reasons I won't get into. This is easy to remember because it's the car company, AAA. So to sum up, you could memorize side, 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 angle, angle, and angle, angle, side. Or you could memorize AAA and ASS do not work. Your choice. Say if the two triangles are congruent. If they are, state why. Well, we have two angles of this triangle congruent to two angles of this triangle, and the corresponding non-included sides are congruent. Do we have an angle, angle, side? We sure do. These are congruent by the angle, angle, side postulate. Well, let's be more specific. Angle, angle, side congruency postulate. We need that because there's other angle, angle, side postulates we'll learn later that is not congruent. All right, number two, at first glance, you'd be like, well, no, this doesn't work. We only have two things marked in these triangles. We need three things marked in the triangles. Well, that's true, but check this out. These are vertical angles and they're congruent. Whoops. Different markings than the other angle that was given. One arc, two arcs, two dash. One arc, two arcs, two dash. They're in the same order. So this is yes, once again, by the angle, angle, side congruency postulate. Number three, those correspond, those correspond, those correspond. So this must be yes by the angles. Uh-oh, that's not one of them. This is no. If it's no, you don't have to give a reason. This would be angle, side, side. This would be angle, side, side. This previous one, it would be angle, angle, side, angle, angle. If you called this side angle, angle, that would be okay. This one is also angle, angle, side, angle, angle, side. All right, number four. We got vertical angles again. That is the universal sign for a community. This is angle, side, angle. Angle, included side, angle. That's certainly one of them because it's not the bad word or the AAA. Number five, well, it looks like this one would work, but it actually doesn't. We got side, angle, side. And here we have angle, side, side. They're not in the same order. This has the angle included. This has the angle non-included. Those are different things. Number six, the reflexive property says that this segment here is congruent to itself. So is there an angle, angle, side? Sure is. Angle, angle, side. Yes, by the angle, angle, side congruency postulate. Number seven, similarly, this segment's congruent to itself. So angle, side, angle. Angle, side, angle. It's not the bad word, and it's not AAA. So yes, angle, side, angle, congruency postulate. Number eight. Well, if this forms a 90-degree angle, then this one has to also be a right angle. And this side is congruent to itself. This is angle, side, angle again. Number nine, reflexive property. The segment is the same length as itself. This is side, side, side. All right, let's get to what we came here for. Proofs. Given angle X is congruent to angle I. It's not in the picture. Let's put it in the picture so it's more obvious to us. Segment XJ is parallel to segment IH. Prove that triangle JHI is congruent to triangle HJX. So we first write down what's given, which is already written for us, and the reason is given. Normally we try to take what's given and try to make it into equations. Since we're trying to prove two triangles are congruent, we need things that are congruent to each other. Hopefully you can see this is congruent to itself. Hopefully you can also see we got two parallel lines cut by a transversal. So wouldn't it be reasonable to assume that this angle and this angle are the same because of the alternate interior angle theorem? Let's do that one first. If we extend this line and extend this line, auxiliary lines, and extend this line, we're going to find the angle XJH is congruent to angle IHJ. Reason, the alternate interior angles theorem. Then once again, one of the original things that I said was this segment is congruent to itself. It's a reflexive property. So segment JH is congruent to segment JH. Congruence of segments is reflexive. Once we get this, then we can hopefully see that we have angle, angle, side, angle, angle, side. Got one arc, two arc, one dash going in this direction, one arc, two arcs, one dash going in this direction. So now we can confidently say that triangle JHI. Now when I do this, I need to be careful. I went two arc across the one dash, then across the angle that had no markings. So when I name this other one, I need to start with the one that has two dashes, which is angle H. Then go across the one dash, and then, I'm sorry, that's not an S. Going across the one dash gets me to a J. And then takes you back to the last letter, which is X. HJ, HJX. When I was first showing you this, I was pointing at the wrong triangle. JHI goes, yeah, I'm sorry. Let me re-explain this. We're looking, first of all, let me highlight this to make sure this is more clear because I'm doing just a terrible job. Okay, this triangle first. JHI, no markings, two arcs, one arc. So when I go to this other triangle, I need to start at no markings, H, one marking, JHI, none, two, one, none, two, one. Sorry, I made that so much more complicated than it is. And this, the reason we can say this is by the angle, side congruency postulate. All right, let's see if we can butcher this next one. Given segment AC is congruent to segment BC. The picture does not show that, so we are going to mark it. Next, we have segment CP is perpendicular to segment AB. Picture does not show that. We're going to mark it. We're trying to prove that this triangle is congruent to this triangle. So let's see what we can do. Obviously, we have what's given. Once again, we're not going to try to make equations of this because if we just need things, pairs of things that are congruent in order for us to establish two triangles are congruent to each other. Now, before I continue, there's a blank here that you may or may not want to fill out. Like, can you look at this right now? Can you tell why these two triangles are congruent? I mean, you might be able to see, well, this is congruent to this. These angles are going to be congruent, and this is going to be congruent to itself. So you might say angle side side. Oh, but that's not one of our theorems. So maybe we don't know right away what this is. So let's see if we can figure this out. I think we would agree that this angle and this angle are right angles. So angle CPA and angle CPB are right angles. I wrote that high because I didn't know if I'd have enough room to get it in. How do we know those are right angles? Well, we were told this was perpendicular, so it's definition of perpendicular. Now we can say that those angles, angle CPA is congruent to angle CPB, because earlier in the year we had a theorem that said all right angles are congruent, had no name, so we just write down the whole theorem. All right angles are congruent. All right, so now we have a side that is congruent because we were given that, a pair of sides and a pair of angles. Would you agree that this big triangle is an isosceles triangle? I would certainly agree with that. Of course I would, I said it. Triangle ACB is isosceles. How do I know that? What's the definition of isosceles? What does that do for me? That tells me that angle A is congruent to angle B. What does the fact that this is isosceles have to do with these being congruent to each other? It's the isosceles triangle theorem. Now that I know that that's congruent by the isosceles triangle theorem, we have angle, angle, non-included side. Angle, angle, non-included side. So we can say what we were trying to say, triangle ACP is congruent to triangle BCB, BCP. We'll look at that in a moment to make sure I got those in the right order. And that is by the angle, angle, side congruency postulate. Are these in the right order? ACP. A is 2 arcs to 0 arcs to 90. BCP, 2 arcs to no arcs to 90. They're in the same order as what we were trying to prove, so we're finished. And that's it for this. There are going to be some proofs in your homework, and they're going to be complicated. Try your best.